Okay, today we're going to talk about water and its ability to be in equilibrium with its ions and the pH scale. Okay, so I'm not going to read everything word for word, you can read through it, but I do want to talk about the fact that water is amphoretic, which means that it can break down into ions, and that's why sometimes water can produce a little bit of electricity. But with that being said, and we'll look at the kW constant here in a second, even though it does self-ionize, the amount that it self-ionizes is very minimal, okay? And you can see here it says only about 2 in a billion of water molecules are ionized at any instant, okay? However, since it can self-ionize, this would be ultimately the reaction that we're looking at when we're talking about the self-ionization of water. Sorry, it wasn't showing what I wanted it to show. So this would be the self-ionization of water. Okay, and you'll notice that you have your H3O plus and your OH, okay, which means one of the waters gives a hydrogen to the other and the other one loses. Okay, now you will also see in shorthand this equation written something like this, where you don't have the hydronium ion. Okay, so this is sort of a shorthand for this equation. So I just need you to know that when I write this, you should be thinking that the self-autoionization of multiple water molecules. Okay, so the expression that you see, it's referred to as kW. So in our last unit, we talked about Kc, which was concentration. So kW is going to be the equilibrium constant for water. Okay, so in pure water, our kW equation, so if we look here, you have to remember that when we write equilibrium constants, we omit liquids and solids. Okay, so if you look at this equation, both of my water molecules are liquids. Okay, so when I write my kW for this equilibrium constant, I'm only writing the products that I make. Okay, and what we find is that kW stays the same, and that kW is just 1.00 times 10 to the negative 14th, which is what we're going to talk about. This is where that negative 14 is where we get our pH scale from. Okay, and that's at 25 degrees Celsius. And we'll talk about Ka and Kb and what that means here later in this unit. Okay. Okay, so with that being said, if we know the concentration of OH and H+, we can figure out whether a solution is going to be acidic, basic, or neutral. Okay, so if they're equal to each other, it's obviously neutral. That means that one thing doesn't overpower the other, so we're going to be at 1 times 10 to the negative 7th. Okay, however, if I have more OH, you have to remember that OH negative means that I'm more basic, where the H plus means that I'm more acidic. And by H plus, I also mean that H3O plus is what we're talking about there as well. Okay, so if I have an OH bigger than H plus, the solution is going to be basic, where if OH is less than H plus, obviously the solution will be acidic. Okay, so let's look at some examples here that we have down at the bottom that in reference to this. Okay, so let's look at this. It says at 60 degrees Celsius, the value of kW is 1 times 10 to the negative 13th. Using Le Chatelier's principle, predict whether the reaction below is exo or endothermic. Okay, well, since this is a small value, we're going to indicate that this is going to have to be an endothermic reaction, because you're going to have heat put into the reaction in order for water to self-ionize. Okay, and then it asks us to calculate the H plus and the OH in a neutral solution. Okay, so what that means is if I have this value, okay, I can plug that into the equation to figure out what each of those is going to be. And to do that, what I can say is, okay, well, kW is equal to H plus times OH minus. Okay, and I have kW, it's equal to this 1 times 10 to the negative 13th. So I can say Kw is equal to 1 times 10 to the negative 13th. This is a neutral solution, so that means those two are going to be equal to each other. Okay, so I'm going to set that equal to x times x, which is just x squared. Okay, so to solve this problem, I just have to, which is just x squared. Lost my... So in order to solve for x, I just take the square root of both sides. And when I plug that into my calculator, you have to remember that you have to use that EE button. Okay? So you do the square root of 1e negative 13, and you get 3, since I only have one sig fig, I'll just do 3 times 10 to the negative 7th. Okay, so in a neutral solution, these two concentrations are 1 times 10, or 3 times 10 to the negative 7th, and it's going to be molar because we're in a concentration. Okay, let's do some other examples here. Or actually, let's talk about the pH scale first, and then we'll do some examples. So now that we know how to calculate H plus and OH, we can use this to move into our pH scale. Okay, so our pH scale, we have to realize, is based off of these really, really, really tiny numbers. So we actually want to use logs to flip them and actually make them make sense on a 0 to 14 scale. Okay, so if you remember what log is, every time you, like, so for example, 1 times 10 to the negative 7th, if you log that, that makes your negative 7 a 7. Okay, so then you can plug that into your pH scale, which would make then it neutral. Okay, so there's a couple of things here that you can read, but I just want to do some practice problems. So you can kind of see how we calculate pH from the H plus and the OH concentration. Okay, so let's look down here at number 6. Okay, so the question is asking, it's calculate either the H plus or the OH from the information given and state whether the solution is acidic, basic, or neutral. Okay, so you have to remember that Kw is equal to H plus times OH minus. And I know what Kw is, and I'm given OH, so I can solve for H plus. So Kw is 1 times 10 to the negative 14th. I'm solving for H plus, and I'm given 1.0 times 10 to the negative 5th molar for OH minus. So to solve for x, I divide both sides by 1.0 times 10 to the negative 5th. So x will be equal to 1.0 times 10 to the negative 9th molar, and that's my concentration of H plus. Okay, OH minus here, I'm sorry, I need to state whether it's acidic or basic. This is going to be basic because this concentration is greater than this concentration. So this solution will be a basic solution. Okay. Since Kw is 1 times 10 to the negative 14th, I know that H plus concentration is also going to be 1 times 10 to the negative 7th, which makes this a neutral solution. Okay. Where down here, I have a 10.0 molar solution, so I'm going to do Kw is equal to H plus times OH minus, sorry, my pencil keeps breaking, OH minus, so I have 1 times 10 to the negative 14th is equal to 10.0 molar, well, you don't have to put that, well, yeah, let's just put it, molar, times x. To solve for x, you divide both sides by 10, so x will be equal to 1.0 times 10 to the negative 15th. And since this is a bigger number, this is really, really tiny, that means that this solution is going to be acidic. Okay, let's look at a couple more problems here. Okay, so how do I calculate pH and OH? Okay, so this question says, calculate pH and OH for the following solutions. Okay, so it's easy to calculate OH given, or POH when I'm given OH, so I'm going to say the POH is equal to the negative log of the OH. Okay, so then I can just plug that into this equation. So the POH is going to be the negative log of 1.0 times 10 to the negative 13, which is equal to 3. So that's the pOH. And if we remember, our pH scale is on a scale of 14. So to figure out pH, you have to remember that 14 is equal to pH plus the pOH. Okay, so to solve for that, the pH will just be equal to 11. Well, it'll be 11.00 because I have those two significant figures after the 3. Okay. What if I'm given a 1 molar pH here? Okay, so to solve, or an H plus, so I need to do pH is equal to the negative log of H plus, which is equal to the negative log of the 1.0, which turns out to be 0. The log of 1 is 0, okay? Which means the pOH is going to be equal to 14, because then you're doing 14 minus 0 equals 14. Okay? Exercise 8, it says the pH of a sample of human blood was measured to be 7.41. Calculate pOH, H plus, and OH for the following sample. Okay, so with that being said, we have to think about this. So it gives me the pH. So it says pH is equal to 7.41, which means that pOH is equal to 6.59. Okay, now I have to figure out how do I find the H plus and the OH. Well, I'm just going to inverse log. All right, so inverse log is negative 10 to the negative pH and 10 to the negative pOH. All right, so to find the H plus concentration, I have to do 10 to the negative pH. So 10 to the negative pH is going to be 10 to the negative 7.41, which turns out to be 3.9 times 10 to the negative 8th, so that's my H, this is my H plus concentration, okay, where 10, I don't know why I just did that, where 10 to the negative pOH is equal to 10 to the negative 6.59, which turns out to be 2.6 times 10 to the negative 7th, and that's the concentration of OH minus. That's it for this video. Thanks.